We are doing question number 3 here. We are done with part A. We found the function. Then we did part B to predict what will be the population on 2018. Now it's asking use the function from part A to determine the year during which the population of California will be twice the value of 2000. So in 2000 the population was 34. So we want to find the time when population will become double from 2000. So that means double of 34. What is the population? 34 times e raised to power 0.00926t is equal to double of 34 is 68 million. So we need to find t. So let's divide both sides by 34. So we have e raised to power 0.00926t is equal to 2. We need to get rid of everything except t. So I am going to take natural log on both sides. Natural log and e exponential are inverse functions of each other. So we are left with times t is equal to natural log of 2. So t is equal to natural log of 2 divided by this number. You can use calculator for the calculation. 74.85. I'm going to round it up to 75. So 75 years since 2000. So that means in year 2075 population will be twice than year 2000. 75 years will take the population to be double. Next we have, let's do example number 4. Write an exponential function with base e. The population of a culture, bacteria, is given by p of t. The function is given to be 5000 times 2 raised to power t by 4, where t is the time in hours since the culture was started. Write the rule of this function using the base e. Now here we have a little fact. Writing an exponential expression using the base e. If t and b are real numbers and b is a positive number and not equal to 1, then b raised to power t can also be written as e raised to power natural log of t times t, because we know that exponential and actual log, they are inverse function of each other. So they are going to cancel each other. So we're going to left with b raised to power t. So that means what they're asking here, we're going to use that. We want to write this function as the base e. Right now it is written as the base 2 raised to power t4. So 2 raised to power t by 4 can be written as e raised to power natural log of 2 raised to power t by 4, which would be e raised to power natural log of 2 times this power comes out, right? T by 4. So we are saying population function can be written as 5000 times e raised to power t by 4 times natural log of 2. Now it's an exponential function. Find the population after 12 hours using both forms of the function. So now we need to figure out population in 12 hours. Let's use the first form of the function, 5000 times t raised to power 12 by 4. Now we know 4 times 3 is 12. So that means 5000 times 2 raised to power 3. 2 raised to power 3 is 8. So I can say 5,000 times 8 is 40,000. So the culture's population after 12 hours would be 40,000. So they are asking use both methods. Let's try second method. 5,000 times e raised to power t by 4. So in place of t, we have 12 by 4 times natural log of 2. So 12 by 4 is 3. So we have 5,000 times e raised to power 3 times natural log of 2. Let's use calculator for that. E raised to power 3 times log of 2. Whatever the answer comes times 5,000. It's the same answer. We wanted the same answer, right? We said these both functions are basically the same thing written in two different forms. Let's look at example number 5. Carbon 14 is an element, has half-life of 5,730 years, meaning if you have a given amount of carbon in 5,730 years, it will become half of that. It keep on decomposing itself. Write a model of the form Qt, where Qt is equal to Q naught times e raised to the power negative kT. Now notice, because it's a decay function, the carbon is decaying over time, the power is negative. To represent the amount of carbon after T years if no additional carbon is ingested. So the question is Qt is amount of carbon in T number of years is given as Q naught times e raised to power negative kT. That is the question. Write a model. Now we need to figure out this function. Okay. So let's say we have whatever the initial amount is in 5,730 years. Half life of carbon 14 is given to be this. Meaning if T is equal to 5730, where Q naught is the initial value, the Qt will become Q naught by 2, half of the initial value. So we have Q naught times e raised to the power kT is equal to Q naught by 2 when T is 5,730. So using this expression, we can find K value. We can divide both sides by Q naught. So we have e raised to power negative K times this equal to half. We can take natural log on both sides, taking log on both sides. Log and exponential cancel each other. We are left with the exponent only. So K would be natural log of half divided by negative. Let's use the calculator. So we have 0.00012009. So what we are concluding here is that our growth function is equal to Q naught, whatever Q naught is, that is the initial value, times e raised to power negative 0.00012009 times T. In T number of years, carbon 40's amount can be written as this value, where Q naught is the initial value. An archaeologist uncovers human remains at ancient Roman burial site, finds that 76.6% of carbon 14 remains in the bone. How old is the bone? So, this is a model to figure out the age of the old burial site. Now, we have to find T when the amount of carbon is 76.6% of initial value, whatever it is. That means Qt is equal to 0.766 times Q naught. We figured that Qt function is already Q naught times e raised to power times t is equal to, we now know that that is equal to this. We can divide both sides by Q naught. This will cancel. So we have e raised to power, this number is equal to 0.766. We can take natural log on both sides. Natural log and e cancel each other. So we are left with is equal to natural log of 0.766. Let's use calculator for that. Natural log of 0.766. We need to find t, so we'll have to divide both sides by this number. So that fossil which we have found is 2205 years old.